We're going to be working with some more dilations, only we call them scale models and maps. And this will be chapter 5-7. A scale model really means that it's a similar figure to the actual object it represents. Some of you may be familiar with model airplanes or model trains. Even some of the Star Wars toys, for example, are based on a scale that's supposed to have come from the movie models, okay? We're going to be working with the scale. It's another word for scale factor. It's the ratio of the length or the width of the model to the corresponding length or width of the actual object. Note that I have this written out here, that the scale, or scale factor, the scale is equal to the length or width from the model over the real. It's model over actual, or map over actual. And we want to get that scale so that our numerator is 1. That probably means that I'm going to have to divide both the numerator and the denominator by the numerator. If we look at example A, hopefully this will be kind of clear. We are going to draw a 6-inch by 8-inch rectangle on a piece of paper that is really going to represent a roof that's really 300 feet by 400 feet. So you can see that this obviously has applications to blueprints and architecture. What we want to do is find the scale of the drawing. We really only need to take one of these measurements, but again, we need to remember that the scale is equal to the model over the actual. So in this case, I'm just going to pick the corresponding measurements. I have found over the years that if I put my labels in, it is a huge help. And a lot of students don't like to do that, but really it's helped me out tremendously. Now remember, we want to get the numerator to be 1. That means we're going to have to divide this number by 6. It means we're going to have to divide that number by 6. 300 divided by 6 is 50. So our scale here is really 1 inch equals 50 feet, or 1 inch to 50 feet. Now sometimes they will write that as 1 inch equals 50 feet. Sometimes they will put it in more ratio form using the colon. So you have to be able to recognize it in whichever form they show it to you. One of the ways in which we use scale factors is to find the sizes of models or to determine the actual distances if we're using a map. Yeah, I know GPS probably gives this to you, but once upon a time we actually did this with map. Okay? We're going to go through example B here. There's a Museum of Science and Industry down in Chicago. I don't know if you've ever been there, you've ever heard of it. It's an amazing, amazing place. They have a model heart that is based on the scale. 1 foot of the model is 9/32 of an inch of a real heart. I was at this museum years and years ago. You can walk through this model since it is 16 feet high, and when you're standing inside, you can actually hear a recording of a heartbeat, lub-dub, lub-dub. If you ever get an opportunity to get down to the Chicago Museum of Science and Industry, I would really recommend it. It's a great place. Kind of a neat getaway. You can maybe get down there to the Chicago area for a day or so. It takes a long time to go through. It's really a neat place. And I hope you can find this model if you ever get there. The first thing, of course, is we need to remind ourselves that it's model over actual. And I tell myself that all the time, even now, after all these years of working with this, I keep telling myself, model over actual, model over actual. Now I'm going to write it. 1 foot over 9/32 of an inch. Now, model is 1 foot. The model here is 16 feet high. So that has to be in a top position. Both model measurements, if you're working with proportions, both of the model measurements have to be in the numerator position if we start for working with a scale. Okay? And then the actual has to be in the denominator position. I don't know. So I'm setting up a proportion. This is where I go back to using cross products. Okay, this goes back to lesson 5.4, I believe. 1 times n is n. Then I'm going to take 9 over 32 times 16. But remember, that means 16 over 1. Now, I look for diagonal reducing. 16 goes into 16 once. 16 goes into 32 twice. Now, here's another one. The other lesson I told you, 2 times 18 is 36. Okay, 2 times 16 is 32 is an important mental math arsenal. Okay, now I go to multiplying fractions. 9 times 1 is 9, over 2 times 1 is 2. Now I reduce this to lowest terms, 4 1/2 inches. The nice thing about using labels in your proportions is you'll know what the label on your answer has to be, because you can tell where the n is. The n is by the inches, so therefore I need to know inches. Okay, we're going to move on with the same heart, only this time we're going to talk about the width of the heart. Now again, it's model over actual. So I have 1 foot, 9/32 of an inch. So the scale becomes the part of the proportion that I do know. Okay? The width of the heart is 10 feet, and I do not know what the real heart's width was. 1 times n is n. 9 over 32 times 10 over 1. Again, I'm going to look for reducing. I don't have a very nice one here. The best I can do is a 2. So n is going to be 45 over 16. I'm going to divide that out. Remember how to do that? I hope. Right. 45 divided by 16. I'm going to get 2, which is 32. And we'll express that remainder as a fraction. Why don't I use a calculator and use a decimal? Because quite frankly, if I'm using a ruler, I'm going to be able to count 1/16 of an inch on a ruler. Okay? You try D, and then I'll go over it. Okay. Again, I'm going to remind myself that it is model over actual. I'm going to get 1 inch over 75 miles. That's my known part of my proportion. Now, what do I have in my problem? Do I know the inches or do I know the mile? Well, I know the map distance. That's the inches. That has to go on top because model is the same as saying map over actual. Okay? And I do not know the real distance, so that's going to be n. I use my cross products. 1 times n is n. This time I am going to use a calculator. 75 times 1.75, and I will get 131.25 miles, the distance between the two towns. And that completes lesson 5-7, scale models and maps.